We're finding what angle has a sine value of negative square root of 3 over 2. So remember, when you're looking at your unit circle for sine and tangent, you're either in this quadrant or in this quadrant backwards. All right, so you have your, if you're looking at the unit circle, you have positive pi over 6, positive pi over 4, positive pi over 3, positive pi over 2, but then you would go backwards, right? Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. So they want negative square root of 3 over 2, and that's my y value. So none of these y values are negative, right? So I drop down here, negative square root of 3 over 2. So if I went that distance backwards as it is forwards, right, that would be a negative pi over 3. What's up? You're just raising your hand? Oh, just to raise your hand. Oh, sorry, Weston. I wasn't recording, and then I was recording, and then I wasn't. Anyway, C is the right angle, so it doesn't matter which angles are A and B. But I'm going to go ahead and label my sides. That way I don't get confused about what I'm finding. So across from angle B is side B. Across from angle A is side A. And then this would be side C. So they told me that angle A, which is this angle right here, is 38 degrees. And side C is 8. So I have to find everything that I am missing. So the easiest thing to find would be my angle, because I already have this one. So I know that angle, that's not an L, Weston. Angle B is equal to 90 minus the angle that I have. So I know that angle B is equal to 90, let's see, minus 30 is 60, right? So 52. Am I doing my math right? Okay. 52 degrees, so that's one thing that I was missing. And then I told you guys that I like to use what I was given in the event that I subtracted wrong. So then you would at least get the rest of it right. So I have this angle right here, and I have this side, and this side is my hypotenuse, right? In reference to this angle, this side right here is the opposite side, and in reference to this angle, this side is adjacent. So if I want to find side A, that in reference to this angle would be the opposite side, and the side that I have is the hypotenuse. So if I'm doing opposite and hypotenuse, I would do sine. So sine of 38 is equal to the opposite side, which is what I'm trying to find, over the hypotenuse, which I already have. So I'm just going to multiply by 8. So side A is, and I'm going to put an approximate because this is not exact. And you plug in 8 sine 38, and you get 4.9. Did you guys have this part right? Yeah. Okay. And then if I want to find this side, that would be adjacent over the side that I have, hypotenuse, and that would be cosine. So cosine of 38 is equal to the adjacent side over the hypotenuse, and then I'm doing the same thing and multiplying by the 8. So B is approximately 6.3. So if you will label your triangle in the beginning and make sure that you have the right sides and really focus. If it helps you to put what side that is in reference to the angle that you're going to use. You could have used this angle. It's just I like to use what I'm given just in case I messed up finding that. Then I wouldn't get the whole thing wrong. Okay. Sometimes that's unavoidable, but all right. Then number 15. Ooh. All right, again, they're telling you that C is your right angle. So this is C. I'm just going to say that this is A and this is B. And I'm going to label my sides. So across from B is side B, across from A is side A, and across from C is side C. Angle B is 37. Side B is 12. So since we have an angle right here, I can go ahead and subtract from 90 to find angle A. So angle A is equal to 90 minus 37, which is 53. So in reference to the angle that I have, this side of is the opposite side. This side is the adjacent side. And then the C is my hypotenuse since it's across from the 90-degree angle. So if I want to find the adjacent side, I would have to use the side that I have, which is the opposite side, and then the adjacent side. So that would be tangent. So tangent of 37 is equal to the opposite side over the adjacent side. And I have to get that A off the bottom, so I'm going to multiply by A. And now, to solve for A, I divide by the tangent of 37. So A is approximately 15.9. All right, then the only other side I need to find is my hypotenuse. So I would do opposite, because that's the side that I have, and the hypotenuse is the side I'm trying to find. So opposite and hypotenuse is sine. So sine of 37 is equal to 12 over C. And then I'm going to get that C off the bottom just like I did with the tangent. So I have C sine 37 is equal to 12. Divide by sine 37. And C is approximately 19.9. Another good way to kind of just, check to see if maybe you're way off too is you know that A is 53, right? B is 37 and C is 90, correct? So the longest side will be across from the largest angle. So C should be the biggest, right? Followed by the next biggest number is 53. A should be the next biggest. And then the smallest side should be 12. So if you look, 19.9, that's the biggest, right? 15.9, that's the next. And then 12 is the smallest. So if you're like really off, you should be able to tell if you kind of do that to kind of check yourself. Are you guys good with that one? Yes. hmm Did it come out right? And it still may not come out right because you rounded this. You know what I'm saying? Sometimes you might get lucky and it come out properly. Does that make sense? But really, the only time that I'd be okay with you using the Pythagorean theorem is if you already had, like, you had a few problems maybe where you had, like, um, let's say they gave you this side and they gave you this side. Those are given items, right? You didn't find those, and they're exact. So you could do the Pythagorean theorem to find your hypotenuse. Like, that's acceptable. But if they give you an angle on a side, don't do the Pythagorean theorem. Use your trig functions. Because otherwise, when you start using rounded answers, sometimes they end up being off. And sometimes you get lucky, but not always. But that's a good question. Okay, are we good on that one now? Okay. Number 16. All right. We have a park that's showing a movie on a lawn. The base of the screen is 6 feet off the ground. Okay, so we have a movie screen right here. And I'm just going to put like a little pole here because apparently it's sitting on top of something, right? Something that is 6 foot, correct? This is 6 foot from here to here. And the screen's 22 feet high. So from here to whatever the base is 22 feet. Find the angles of elevation to the top of the screen from 15 feet away and 100 feet. So in other words, someone's sitting closer to the screen and someone's sitting farther away, right? So let's say that this is the 15 foot to the top. And then you have another person, and I'm going to draw this in blue, that is 100 feet away. This is not drawn to scale. Okay, so they want the angles of elevation, right? So if I'm sitting here and I look up to the top of the screen, this would be one angle of elevation, right? And then the other would be if I was sitting farther away, looking up to the top of the screen, this would be the other angle of elevation. So let's just call this one, just to give it a name, we'll call this A. And then let's just call this one B. Okay, so the very first one we're going to focus on is this pink triangle right here, right? Ooh, only I drew this wrong. You're not sitting in the air. Sometimes I crack myself up. I'm going to move this. You guys get what I'm saying? You're on the ground, not on the air. Okay. That might be helpful. Okay, we're on the ground. 15. And we're going to find that, which we're calling that A. And then you have another dude that's 100 feet out. And we're calling that B. And that's 100 feet. Okay. Well, that makes a little more sense now that we're not hovering. So for this pink triangle, right, you need the whole side of this, right, if you're going to make the whole triangle to go with this angle of elevation. So you have to count the 22 feet for the screen and the thing that it's sitting on. So this whole side is 28 feet, correct? And it's the same for your big triangle too. It's still the same distance from the ground to the top of the screen. All right, so I want to find this angle, and I have the side that is opposite of that angle, and I also have the side that is adjacent to that angle. And I know that because this has to be my 90-degree angle, and that's my hypotenuse, right? So opposite and adjacent, that would be tangent. So tangent of my angle is equal to the opposite side over the adjacent side, which is 15. And remember, to get to your angle right here, you have to do the inverse of tangent. So angle A is equal to tan inverse of 28 over 15. And I literally just plug that in. So 61.8 degrees is the angle of elevation when you're 15 feet away, right? If you had a problem like this where you were finding two different things, you would need to make sure that you told me that this was for an angle of elevation of 15, right? Then you're going to do the same thing for this angle. That's still opposite, and you still know the adjacent side, so you're still using tangent of your angle is equal to, but this time the adjacent side is not 15, it's 100. So I've got 28 over 100. And then I want to access and solve for angle B, so I do the inverse of tangent. All right, so I get tan inverse of 28 over 100. That gets me 15.6 degrees. And always ask yourself, does that make sense? And that's true, right? If you're farther away, you wouldn't have as much to look up, right? If we're sitting right next, it's like when you sit too close in the movie theater and you're like literally looking like your head is tilted all the way back. Okay, you're lying on the ground, and the angle of elevation to the top of the screen is 42 degrees. So again, you have your screen and the thing it's sitting on, right? And you're laying on the ground, but this time they're telling you that the angle elevation is 42 degrees. How far are you from the screen? That would be this distance, right? This is still the same height, right? We're still 28 feet from the ground. So the side that I have is the opposite side, and the side that I'm trying to find is the adjacent side. So opposite and adjacent is tangent. So tangent of the angle I'm given is equal to opposite, 28, over adjacent, which is what I don't know. Let's just call it A. So I have to get the A off the bottom. So I have A tan 42 is equal to 28. And then divide by the tan 42. So we're about, if you plug that in, 31.1 feet away from the screen. I have a question. Where, and this goes for Westin too. Westin, I'd let you ask your question, but you're not here with us. He has trouble figuring out, like, if he's trying to find this angle, what he's supposed to use. Do you guys have trouble with that? See, I don't understand that. You guys will have to help me understand. Because I identify what I'm trying to find, right? If this is what I'm trying to find, then I need two pieces of information, right? Because in every problem, there's three pieces of information. Like, you've got an angle, that's one piece, right? And then you have something over something. So you have three things total, right? Three things total, correct? In every problem. So if I'm given an angle, so let's say I'm given this angle, then I need at least one side, right? Okay? If I'm given two sides, then I can find an angle, right? Or if I'm given one side, then I either need another side or an angle, right? So I always identify what I'm trying to find. So I'm trying to find an angle, right? That fills in for this part. So now I'm looking for two sides, right? Then I look at that angle and I say, okay, this side is opposite, and that's a piece of information that I know, right? This side is adjacent. That's a piece of information I know. So I'm using opposite and adjacent. But I am not using hypotenuse because I don't know that. And I have to be able to fill in two items out of the three. So like on this one, I look at it and I go, okay, oh, I have an angle. I know this side, and that's opposite. And I'm trying to find this side, and that's adjacent. So I'm using opposite and adjacent. That's tangent. So tangent of my angle that I'm given equals opposite. I know that. Divided by adjacent, that's what I don't know. So always find the part you don't know and two pieces that you do know and make sure that they match up. Like, you wouldn't say that that side is the adjacent side, right? That's the opposite. So make sure you put that in the opposite spot. So if it helps you to write the SOHCAHTOA at the top of your paper, then write that and say, okay, sine. So if I have these two, like if one of these is like, maybe I don't know the opposite, but I know the hypotenuse, right? It doesn't matter. I'm using opposite and hypotenuse. Or if I have the adjacent, but I don't have the hypotenuse, and that's what I'm trying to find, I'm using adjacent and hypotenuse. Are y'all with me on this? So always locate what they gave you, because they're always going to give you two things. Figure out where the thing you're finding is, and then figure out how they relate to each other with opposite and adjacent, or adjacent and hypotenuse, or opposite and hypotenuse. And then use that trig function. So hopefully that makes sense. Do we have any other questions other than that? I will say this, though. You guys are not alone in the whole trying to figure out what you're supposed to use part. I have never that's one thing I never struggled with, so I don't understand why that's difficult. Some things I understand. Like, I get why that was difficult. You know what I mean? Like, I have an understanding for it. And this I don't. Like, have you ever done something and someone else had trouble with it and you're like, why are they even having trouble with this? It's like that for me with this. But like, I'm trying to have an understanding, because it's a problem for a lot of people, even in geometry, because you guys do this in geometry. And she's always saying, I don't understand why they don't get this. But anyways, so no other questions. There's nothing we need to, no other ones that we need to go over. Okay. Yes. Yes, I will. Do you guys have more trouble finding an angle or a side? Yeah. Yes. Okay. Do you guys have trouble drawing your triangle? Oh, okay. All right. So I'll draw this one for you then. I'm going to give you two. Okay, two separate ones, and then you guys can do them. Let's go with these 32, and your hypotenuse is 13. Hang on. These would be hard to pull out of my rear, so just hang on a second. 9. I got to make sure that okay, I think that one will be okay. If not, we'll find out in a minute. Okay. Do those two right there. I don't know if I was not recording well ago or not. Just find side A on this one and find angle A on this one. Okay, Weston, we just talked about this, but I wasn't recording. So when you're deciding what to use, you always look at the angle and label your sides based on that angle. If I'm standing right here in this angle, this side is the adjacent side. So I'm trying to find that side. The side I'm given is this side right here, which is across from 90 degrees. That's your hypotenuse. So if I'm using adjacent and hypotenuse, that's cosine. It's like cosine of my angle is equal to the adjacent side over the hypotenuse side. So my angle is 32. The adjacent side to that angle is A, and the hypotenuse in this triangle is 13. The hypotenuse is always the hypotenuse, right? The adjacent and opposite just depend on which angles that you were looking at. And then you would just multiply by your 13, and that's going to get you, let's see, 13 cosine 32. I can't look. Yes, 11. Okay, so this one. This is what I'm trying to find, right? This is the unknown, the angle. So if I don't know the angle, I have to know two sides, right? So across from this angle, that side would be the opposite, and across, and right here, this side would be the adjacent. So opposite and adjacent, that would be tangent. Tangent of your angle is equal to opposite side over adjacent side. And then to get rid of the tangent so you can get to the A, you have to do the inverse. So if I do tan inverse of 5 over 12, you get, yeah, 22.6. And this is an angle, right? 22.6 degrees. So if you're ever solving for an angle, you're going to have to do it inverse, right? But the main thing is if you're trying to find, if this is the angle you want, then look at what you have and say, that's the opposite side. That piece of information is the adjacent. I have to use